Just waiting the director to say you can go. Action. Click. Okay. Well, hello everyone again. So today I'm going to talk about two specific things for Kubernetes security. Okay. The idea behind this presentation is to explore a little bit about I want to explore a lot about security context in Kubernetes and why we are not supposed to use some of the configurations that we have, or the best ways to use. Okay, so basically I'm going to deploy one pod with a series of bad configurations. It's going to be our vulnerable pod, and from this pod I'm going to show how these configurations allow us to escape the container and access the host that we are using for Kubernetes, and also how these configurations allow us to intercept traffic from other pods in the same cluster. After that, I'm going to show Falco, which is a runtime security tool, so we can visualize or have some kind of alerts about these bad configurations. And pod security admission, which is a Kubernetes feature that we can use to prevent this vulnerable pod, for example, to be deploying the cluster altogether. Okay. So first of all, I'm going to show the vulnerable pod configuration. Despite of what your LLM tool of choice is going to say, all this configuration that I'm going to show is a bad configuration. We are not supposed to use this, okay? So we have a pod, and we start with the security context, configuring this pod to run as a root user. Okay, we are doing this by setting these two parameters, the run as user and the run as group at 0. Just a reminder, if you don't know, these are the user IDs for Linux. Okay, so 0 is the root, from 1 until 999 are reserved for the system, and over 1,000 are regular users. That's why if you go to most of the examples you see in documentations, you will usually see run as user 1000. Why? Because 1000 is the first of the regular users. So we are not using the pod as root. Okay. Besides of running as root, I'm setting the pod to use a privilege mode and allowing it to scale its privileges for the operating system. And I'm adding for this pod all the Linux capabilities. Okay. In Linux we have a series of capabilities, of things of what you can do and you cannot do. These are just some of the examples. And I'm setting and saying to this pod, okay, you can go and do whatever you want. Yeah. And finally, I am mounting the host file system for this pod, and setting this pod to use the same network and the same Linux namespace of the host operating system. So everything that I was not supposed to do, I'm doing here. Okay. Now I will deploy the pod, and let's show the example. So why we are not supposed to do this? Because it will allow us to do things that we are not supposed to. Right? So, see, yeah, okay. So, I have a very simple cluster here, just one control plane and one worker node. Okay, on the left hand side is the control plane. This is just the host file. I'm going to use the host file just to see how you can escape and tamper with the file in the worker node. Okay, so these are the original host files. I have the vulnerable pod deployed. It is running the only worker that I have. I exec into the vulnerable pod, and I can see that I have the host mounted as a volume, so I have access to all the files here. In the worker, just to see that, just to prove that we have the same file system mounted, I'm just creating a file in the worker node, and we can see the same file created in the pod. So we have access to the host operating system here. Just clear who I am. I'm root in the server, in the pod. So again, I did a cat in the host file of the mounted volume of the host, so I can see the original file. So now I'm going just to show how we are. So we already escaped the container, right? So we already have access to the host. Now I'm just tampering with a file just to show that I can do this. I could do much worse, but I'm going to add this phrase by the end of the host file of the worker1 node. There you have it. So from the pod, I not only access the host operating system, but also I tamper with the host file over there. Just moving away, exiting the pod, and just doing a cat in the control plane. You see that the control plane has still the same file as the original one, so there was no issue here. Okay. So, and with this same configuration, I will also have the possibility to use a tool like TCP dump and grab and intercept the traffic from other pods in the cluster, right? So in this example, I have the vulnerable pod and I have a Postgres deployed in the same cluster, okay? Is this one. Okay, so here on the left-hand side, we have the Postgres, and the vulnerable pod is on the right-hand side. I will exec into the vulnerable pod again, and I will start the TCP dump to capture all the traffic from Postgres on port 5432. Okay, just a second. Yeah, so I'm already listening to the port now with the TCP dump, and in the Postgres, I'm going just to log into the Postgres. I can already see all the traffic coming on that port. I will authenticate in the cluster, in the database, sorry. And inside of the database, I'm going to create a row, for example. I can list the databases, and can see we list, and the TCP dump will capture all the databases that are created. Yeah, now I'm going to create a row for my user, for example, and I will create my role with my password, a super secure password. Yeah, great. And we will see that in the TCP dump from the other pod, I can see not only the command, but I can see the password itself. Right? So with all this configuration, we are allowing the pods to do much more than it is supposed to do. So that's why you will see in documentations, in articles, say, oh, don't use as root, don't use this configuration, don't use that. It's because of this, these abilities that these skills that you allow the pod to execute. Okay, and you can see in the TCP dump, you can see the selects that you do against the database and everything, for example. Okay. So obviously, you would like to mitigate this kind of configuration, or to be alert if something of this is happening, or to prevent this to be deployed altogether in your cluster. The first tool I'm going to show is Falco. Falco is a runtime security tool. Is cloud native, is rule based, so it came with a lot of rules already created for you, but you can create and customize your own rules, and it does real-time detection for you. This is the rule that I'm going to test. So this is the rule that Falco is going to generate an alert whenever someone exec into a pod and opens a shell into a pod. Okay. Okay. So now in the same cluster, I have the vulnerable pods and I have Falco deployed. Yeah. As I say, like Falco is rule based. All Falco rules live in a YAML file. Yeah. As you can see, I'm just going to show in the config map. This is the default location for the rules. Is the etc Falco folder. Now execing into the Falco pod, I'm just going over a little bit the rules file, just to have a glance of the rules and to make sure that the rule that I want to test is there. Yeah. And again, this is just a YAML file. You can create these rules, you can customize and do anything that you want. Yeah. Okay, so the rule is here. So this is it's a default rule. I'm just using the default rule that comes with Falco. There's nothing special, not customized actually. So I exit the pod, and now as soon as I exec into the vulnerable pod, the log from the Falco is going to show up my login, and this rule already come with a message. We notice a shell was spawned in the container. It shows the container name, it shows the namespace. It already gives you by default some informations. Okay, this is a more of a reactive approach because you are being alerted after someone already exec into the container. But obviously you can. This is already good. You can integrate these logs with any observability tool that you already use and create alerts and take actions behind the scenes based on the logs, anything that you want. Okay. Yeah. There is a second approach that you can take, which is a more proactive approach, which is pod security admissions. It's a Kubernetes feature that has 3 standards: privilege, baseline, and restricted. These are a set of security standards that are already shipped into the Kubernetes. So based on the rules that already exist on each of these standards, your cluster is going to prevent, or is going to demand that the pods have certain configurations to be deployed. Okay, privilege is the least restrictive one, and restricted is the most restricted one. Okay, and you have 2 modes that you can implement the pod security admission. One is warning, and another one is enforce. I'm going to show both now. Warning, as per the name, is only going to give you a warning that, oh, your pod has these misconfigurations, for example. But ultimately the pod is going to be deployed. Okay. You will use warning when you are starting with pod security admissions, just to have an idea of what's going to be the impact. Because the second option, which is the enforce, as per the name, is going to enforce all that rules. And any pod that doesn't match all the rules are not going to be deployed. Okay, it's going to prevent altogether. So first thing I'm going to show is the warning. Okay, pod security admissions are enforced at namespace level by adding a label. So in this case, I'm adding the label warning restricted. Okay, so any pod that's going to be deployed in this namespace now is going to be compared with the restricted rule, and if there is something wrong, a warning will appear like this. So for example, I try to deploy the vulnerable pod with all that bad configuration that I show. It gave this massive warning because it's everything wrong. So I'm running as root, I'm mapping the root file system, privilege, true, everything. So it gives me a massive warning, but ultimately the pod was created because we are only using warning. Oops. Sorry. Yep. Okay, so the pod is here. The pod was created even with this massive warning and all this bad configuration. Okay. Good, so the pod is running. Okay, it was deployed with no problems, only with this warning for us. So now what I'm going to do is deleting the pod. I'm going to remove the label from the namespace. I'm going to use the enforce label because I want to enforce the restricted rule. Okay, so I want to prevent these pods that are running as root, or they have like privilege escalation, they have all capabilities to be deployed in this namespace. Again, I add the label with enforce, and now when I try to deploy, I have an error. So it says forbidden. I'm forbidden to deploy a pod that doesn't match all of these rules from the restricted rule. So, see, there is nothing running now. It was not deployed altogether. So only if I match all these conditions that the pod is going to be created. Okay. these are two basic configurations or actions that we can use to secure the Kubernetes cluster. Is runtime security with Falco, so we can create our rules or use the default rules to give us alerts of what's happening in the cluster, and then we can configure to receive an alert or to take some actions on behalf based on what's happening in the logs. We have a more proactive approach, which is the pod security admission, so we can prevent some bad pods with bad configuration to be deployed, and we don't need to trust people to do to follow the best practice, to follow what we want, right? But obviously, this is not the only two actions to secure Kubernetes. It's just two of many. We still need RBACs, policies code, network segmentation, hardening the nodes, network policies, and many more actions that we can take. Okay. Yep, that's it. What I would like to show guys just these two brief actions that we can use to secure Kubernetes cluster. Thank you.